Hello students, welcome to a new video on basic interview questions or oral questions which may ask on design of steel structures. If you are going for interview as a civil engineer or structural engineer, you must know these fundamental concepts of steel structure design. So very first question whenever you are appearing for an interview, very first question which may ask on the steel structure is which IS codes are used in the design of steel structures. As a civil engineer, as a structural engineer, you must know all these IS codes. So very first basic IS 800 2007 which is used for the design of steel structures. General guidelines of steel structures are given in this code. So IS 800 latest revision, that is third revision of that IS code is in 2007. Very first time this code was developed in 1956, that is IS 800 1956, and then revised twice, first in 1962 and then in 1984. Latest IS code is IS 800 2007. You must know this IS code name as a civil engineer or structural engineer. This is used for the design of or construction of steel structures. Along with IS 800, there are few more IS codes which are used in the design of steel structures. That is IS 875 1987 part 1 which is used for the dead loads. Then IS 875 1987 part 2 which is used for imposed loads, that is live load calculations. IS 875 1987 part 3 which is used for snow load and wind load calculations. So whatever design load calculations are there in the steel structures, IS 875 part 1, 2, 3 are used to calculate all those design loads. So part 1 is for dead load, part 2 is for live load, and part 3 is for snow load and wind load. And if you are considering the earthquake load in the design of steel structures, so the IS code is IS 1893 2016. So these are the 5 important IS codes which are used in the design of steel structures. If somebody asks you what are the advantages of steel material over the concrete, these are the few advantages. Strength of steel is of approximately 10 times that of concrete. Steel has large strength to weight ratio, right? Then steel is more economical than concrete if you are using for very tall buildings, high rise structures, not for the small buildings or low rise structures. If you have a high rise structures or very tall buildings, then you can use steel which is more economical than the concrete. Even if you use if it is a bridge, then you can use the steel which is more economical. Of course, we all know that because of the welded and bolted connection, steel structure can be constructed very fast. That is the fourth advantage. Steel structures are ductile and robust and can withstand in any severe loading such as earthquake. And steel structures can easily repaired and retrofitted compared to concrete. So these are the few important advantages of steel over the concrete. Strength is very high compared to concrete, then more economical, construction can be very fast, it is ductile in nature and it sustains the earthquake load, it can be easily repaired and retrofit. Then one more the important question is, what are the different rolled steel sections available in India? During our graduation, we are using steel tables so many times for the design of steel structures. We are using these sections many times, ISMB, ISHB, ISWB, ISA, IEA. But many times students are not remembering what are the full form of all these sections which are mentioned in steel table. So it is very important to remember all this. If you look at, these are the different rolled steel sections available in India which are used in steel construction. So for beams, there are 4 or 5 types. There are many types of sections, but these are the 4 sections, types of sections. ISWB, ISMB, ISHB, ISLB. What is ISWB? It is Indian Standard Wide Flange Beam. ISMB, Indian Standard Medium Beams. ISHB, Indian Standard Heavy Beams. ISLB, Indian Standard Light Beams. So ISLB, since it is a light beam, it is used in very low loading cases where loading is not much, but most commonly used sections for the beams for the industrial sheds or plants, it is ISMB and ISHB. These are the two most commonly used. Okay. Then second is channel sections are there, that is ISJC, Indian Standard Junior Channel, ISLC, Indian Standard Light Channel, ISMC, Indian Standard Medium Channel. Okay, this is channel section. If you look at here, this is channel section, which is also called as C shape. There is one more channel. If you keep it like this, it is a U shape channel. These beam sections in shape, these are all are I sections, right? There is a T section, angle steel section like this. There are two types of angle section, equal angle, unequal angle sections, right? Then there is a T section. There are circular cross sections like this, circular hollow sections. There are square hollow sections. So as a structural engineer, as a civil engineer, you must know what are the different types of steel sections available in India and what are their full forms. You must remember. I repeat again, ISWB means, IS means Indian Standard, right? So ISWB, WB means wide flange beam. ISMB, Indian Standard Medium Beams. HB, heavy beams. LB, light beams. JB, junior beams. JC, junior channel. LC, light channel. MC, medium channel. So Indian Standard Medium Channel, Indian Standard Light Channel, then equal angle, unequal angle. If length of, this is angle section, this is angle section. If this length and this length is same, it is called as equal angles. And if these lengths are different, like this for example, this is unequal angles. Okay, means these two edges are not of same length. Then this is T section. There are some plates, flat plates, strips. So these are all sections used in India for the design of steel structures. Then what are the grades of rebar in India? Whatever bars we are using for the construction, these bars are of different grades. These grades of rebar, these bars are called as rebar. So the grades are given as per the IS 1786 2016, FE 250, FE 415, FE 500, FE 550, FE 600. These are the grades of steel rebar available in market in India. FE 250 is mainly for mild steel and remaining all other grades of rebar are for torque steel, twisted bars, and mild steel are plain bars. FE 250 represent for the mild steel and other 4 are represent for the tough steel. In this grade nomenclature, this 250, 415, 500, 550, 600, these values or these numbers represent the yield stress of that rebar. Yield stress. This is value of yield stress. Okay. If you draw a stress strain curve for this tensile strength of this rebar, so the value of yield stress for this bar is 250, 415, 500, 550 and 600. So many times during your interview this question may ask, if it is FE 250, what that 250 represent? So your answer must be 250 represent yield stress of that steel. Okay. Then what are the properties of structural steel? So property means what is density of steel? 7850. Sometimes it is also taken as 7800. 7850 or 7800. Unit of density kg per meter cube. Please remember. Density of structural steel is 7850 kg per meter cube. What is modulus of elasticity? It is 210 GPa or it is 200 GPa. Okay, 200 GPa or 210 GPa. In MPa, if you want to write down, it is 2.1 into 10 raised to 3 MPa or 2 into 10 raised to 3 MPa megapascal. Okay, these values are in MPa and these are in GPa. 210 GPa or 2.1 into 10 raised to 3 2.1 10 raised to 5 is MPa, right? This is 5, not 3. 2 into 10 raised to 5, it is MPa. What is Poisson's ratio? Poisson's ratio of structural steel, that is represented as mu, it is equal to 0.3. So these are the properties of structural steel. Density 7850 kg per meter cube, modulus of elasticity 210 GPa or 2.1 into 10 raised to 5 MPa. Poisson's ratio 0.3. Next interview question may be, what are the types of structural steels? Different types of structural steels are carbon steel, high strength carbon steel and stainless steel. Many times students are getting confused. Whenever this question is asked, what are the types of structural steel? Students are replying Fe250, Fe415, Fe500. Please remember, these are the grades of rebar, not types of structural steel. Structural steel is of 3 types: carbon steel, high strength carbon steel and stainless steel. Okay. Next question is, what are the types of connections used in steel structures? So there are 3 types of connections are used in steel structures. First is bolted connection, then welded connection, and third is riveted connection. But riveted connection is not used frequently. Only bolted connection and welded connections are widely used in practical applications of design of steel structures. So bolted connection, here some examples are shown. If you look at, these are the bolted connections joining the column with the gusset plate or the beams. So to join this, we are using this bolted connection, or instead of bolted connection, you can directly weld those sections to each other, that is welded connection. So bolted connection, welded connection and riveted connection, 3 types of connections used in steel structures. Out of these 3, 2 are widely used: bolted connections and welded connections. Then what is lacing in steel structures? There are 2 important terminologies you studied: lacing and battening, right? This is battening. B-A-T-T-E-N, batten. So this is battening in steel. Okay. So what is lacing in steel structures? Lacing means if you want to develop a composite compression member or composite column with the help of 2 I sections. If you look at this figure, this is one I section and this is one I section. In isometric view, it is shown like this. This is one I section and this is second I section. And if you want to use these 2 I section combinedly as a one compression member or one column, then you have to join these 2 I section together. Then to join these 2 I sections, if you join with the help of steel plates which are connected like this, this is called as lacing. Lacing consists of connecting the components of compression member. Compression member means column. Components means 2 I sections. So lacing consists of connecting the components of compression member by a system of generally flat plates. So these are the strips of plate, right? Here this is front view is shown here. If you look at, so these are the steel plates and these two are eye sections, two different eye sections. So these are connected like this, and the point here where that lacing plate and column is connected, here we are using either bolted connection or welded connection. Okay. Now if you look at this four figure, there are four figures shown. In the first figure, this is called as single lacing. So one sided only, one plate is like this, then like this. So only in one direction we are moving. So this is called as single lacing. And if you look at the second figure, it is called as double lacing. On both sided, crossing the plates, you are providing the thin plates. This is called as double lacing, two sided. So single lacing and double lacing, there are two types of lacings. Okay. Even in the lacings, you can use the gusset plate at the point where two members are connected. This is called as single angle lacing with gussets. It means instead of connecting only that lacing plate with the compression eye section or compression member, you are providing one additional gusset plate to more strengthening that joint. So this is called as single angle lacing with gusset plate. Okay. So there are two types of lacing, single lacing and double lacing. Single lacing means only in one direction, double lacing in two directions. Okay. So similarly, there is a battening. The second question is battening. What is battening in steel structure? So battening is application is same. Battening is also used for connecting two eye sections together if you are using for the column or compression member. Only while connecting, instead of these small strip plates, we are using thick rectangular plates and connected like this. This is called as battening. One steel plate we are directly using to connect to eye section. This is battening. Okay, and this is lacing. This is lacing. So two concepts. This is lacing and this is battening. So in battening, we are using rectangular steel plates which are directly bolted or welded to the two members of the compression column. So battens are plates. Battens are plates or any other rolled section used to connect the main components of compression member, that is column. Okay. This is also important question as far as your interview on steel structures. Then very basic questions. What is compression member? Compression member, which is also called as column or strut in steel structures. So columns means, or compression member, a member which carries axial compressive force. It is called as compression member, or in other word it is called as column or strut, right? So if you look at first figure, this vertical, these are the columns which are called as compression member. But in steel structure, it is not necessary that compression member is always vertical. It is not mandatory that it is always a column. In the truss design or truss type of structures, compression member may be inclined or horizontal also. That we will discuss in the lower figure. This truss figure is shown here. So please remember, compression member doesn't mean that only vertical column of the building in steel structure, in particularly steel structures. So what is compression member or strut? You can call it as a strut only instead of column. Okay, strut. So member which carries axial compressive force is known as strut or compression member. What is flexural member in steel structure? Flexural members are nothing but beams. Beams or flexural members are horizontal members which are used to carry transversely applied load. Transversely means vertically downward. If you look at this both the figure, these are called as flexural members. these are called as beams or flexural members. These are all flexural members which are used to carry the load because of this secondary beams or roofing material. So beams are flexural members which are used to carry transversely applied load. Then what is tension member in steel structures? Tension member means member in a structure which carries or which subjected to tensile force. Tensile force where? Tensile force in the direction of its longitudinal axis. A tension member is a structural member that is subjected to tensile force in the direction of its longitudinal axis, which is also called as tie member. TIE. In steel structures it is called as tie member. If you look at this truss figure, this is one important question which may ask in this truss figure, and that is, which are the compression member in this truss or which are the tension member in this truss? So always remember, in truss, this green colored member, these are called as top chord members. I repeat, these green color members are called as top chord members, and top chord members are always subjected to compression. So these top chord members are always designed as compression member. Whereas if you look at the red color line horizontal, these are called as bottom chord members. These are called as bottom chord members, and bottom chord members are always subjected to tension. So bottom chord members are always designed as tension member, and top chord members are always designed as compression member. And other than these, whatever members are there, they may be under compression or they may be under tension. After calculation, we have to decide for compression member or tension member how to design these members. But in truss, top chord members are always under compression and bottom chord members are always under tension. Okay. Then what is single shear and double shear? Especially this occurs in steel, because in steel structures we are connecting the steel plates or steel sections with the help of bolted connections many times. So whenever you connect two plates with one bolted connections, for example these two plates, if you look at here, upper and lower, there are two plates and these two plates are connected with this bolt. Okay. Now if you apply a force or if you pull this upper plate or lower plate, then the horizontal shearing force is developed at this point, which is called as shearing surface. Okay, this is called as shearing surface, where bottom of top plate and top of bottom plate are shearing on each other. So this is called, if you look at here, this is called as shearing surface. Okay, so if only two plates are kept on each other, and if you apply a force or if they slip, at the junction of these two plates, shearing force is developed. So this is called as single shear. Why it is single shear? Because shearing occurs at only one plane. This is one plane, single surface. So what is single shear? In a single shear, shearing occurs across a single surface. If you look at the second example, that is called as, what is double shear? In double shear, shearing occurs across the two surfaces. For example, if you look at this figure, there are three plates, top, middle and bottom. Three plates, 1, 2 and 3. Three plates are kept on each other and which are connected with the help of bolt like this. Okay. Now if you pull the middle plate, the shearing will occur between top plate and middle plate at this surface. Okay. Similarly, shearing will occur at bottom plate and middle plate at this surface. So there are two surfaces where shearing occurs, so that's why it is called as double shear. Okay, these are the line diagrams again for single shear and double shear. So in single shear there is only one shearing surface. In double shear there are two shearing surfaces. That's why it is called as single shear and double shear. Okay, I hope all of you have understand the basics of steel structures. You please learn these all basics. If you go with this preparation in the interview, I am sure you will answer all the questions of steel structures. Okay, in the next video we will discuss few more questions of fundamental or basics of design of steel structures which may ask during your interview. Thank you very much.